Okay, I'm back, and this is the second of two lectures on depth perception, and we're focusing on monocular cues. And so again, if you take a look at this outline that you printed out or did whatever in the last lecture, we're dealing with the monocular cues. And if you look at that, you'll see that there are two kinds of monocular cues. Static cues, which means stationary, not moving, and motion parallax, which is actually a movement cue. So the only monocular cue, so you only need one eye to detect it, the only monocular cue that uses movement is called motion parallax. And I would even suggest like pause and go take a little walk, or make note of this and go do it so you can experience it. But for now, I'll have you just imagine that you're riding in a car on the freeway and you're in the furthest lane to the right, so you can look out your window and you can see the ground and you have nothing blocking you other than what's out there. So if you're driving down the freeway, riding, you're not driving, riding down the freeway at 70 miles an hour, and you look down at the ground right beside your car, what does it look like? So think about that for a second, and then I'll give you the answer. So when you look down there, that is moving wicked fast in the opposite direction. So when you look down there, your eyes can't even track. It's going so fast, and it's going backwards. So that is something that's close. So when you look down at something that's close when you're moving forward, it's going wicked fast in the other direction. Then if you lift your eyes up a little bit and you look at maybe some hills that are right near your car, how is that moving relative to you? Think for a second, come up with an answer, and then I'll tell you. So that's going backwards, but not nearly as fast as the ground right next to you. So something that's a little further away from you appears to be moving at a slightly different rate than something that's close to you. If you look even further away to the hills in the distance, they kind of look like they're moving backwards very slowly. And then if you look at even further away, like the moon, or Mount Rainier, it feels like it's kind of moving along with you. So that discrepancy between the movement, the speed, and the direction of the movement for close things that are a little further, and wicked far, that discrepancy is called motion parallax. So if you actually watch on TV or watch some of the animated movies, you'll actually, if you start paying attention to that, you'll see that your brain can be tricked into seeing movement where there isn't, and seeing depth where there is no depth. Okay, all of the other cues are considered static cues, and so we could see them in photos as opposed to requiring video or movement. And so what I'm going to suggest that you do is click on the link. If you're on a computer, click on the link for the brief depth cue PowerPoint, open it up and scroll all the way down to the static cues until you see a bee on a flower. And when you look at those, you'll see examples, and I'll talk through the example, but you'll see those examples. And so the first one is called interposition, and you'll also hear this cue used, this cue called overlap. And I think that word overlap, I think it's a more colloquial way of saying it, but I think it makes more sense to the average person. But the notion of interposition is that if I'm sitting here and I'm looking at something over here, so close to you, and something gets in the middle, it's interposed. So it's posed, it's positioned in between me and whatever it is I'm looking at. So if you take a look at that bee on the flower, you'll see that there's a bee, but there's a little petal right in front of the bee. And so when I look at that, I still interpret that photo as a full bee behind a flower petal, as opposed to assuming that the bee is missing a part. So our brain assumes that when we see something that's not complete, and we see something that seems complete, our brain says, oh, the thing that's incomplete must be behind the thing that's complete. So in that photo with the bee must be complete and it must be behind. So there's depth and there's something interposing itself between me and the bee, and that must be that flower petal. Okay. Another cue that we use is called shading, and you can see it in this picture of me right now, where the window is over here, and so you see light coming in and hitting my face. So this side of my face is lighter than this side of my face, and it's because the source of the light is coming in and this side of my face is getting less light. In that PowerPoint, you'll see a picture of a cat with a frog statue facing the other direction, and you'll see, you can tell the source of the light, and that comes from our brain gets experience with that, because when light comes in, it comes in straight. It doesn't like bounce around things, and so the assumption is if you have different amounts of light hitting, there must be some curvature to that item, because if it were flat, it would be reflecting light at the same rate all over it. Okay, then there's one more category that has lots in it, a category called perspective. And you guys have, I'm sure, heard of linear perspective. And if we go down to the picture in that PowerPoint is a road, kind of like a country dirt road with a tree in it. Linear perspective is the notion that when in reality lines are parallel, when you look at them and they go into the distance, they appear to converge. So linear perspective is the idea that we perceive lines that go, parallel lines moving off in the distance, we perceive them as angled like this. So when our brain sees angled lines, even in a two-dimensional image like that photo, where it's just flat, but we see angled lines, our brain says, oh, the place where the lines are close together must be further away than where the lines are far apart. Okay. The next type of perspective is called aerial perspective, and that's air like air. So, and it's spelled A-E-R-I-A-L, aerial perspective. Sometimes you'll see that called atmospheric perspective, and I actually think that's a better term for it because it tells you that light is passing through the atmosphere. And so with that concept, you can imagine light is bouncing off of particles and getting absorbed and so forth. So the idea that light reflecting off of objects in a distance, by the time it hits you, you're not getting as much of that light as you would if you were closer. So aerial perspective is the idea that things that are close to you appear to you as being crisp, and the color is intense and saturated, and the lines are, you can see detail. And things in the distance, because that light is getting filtered so much, things off in the distance the colors are less saturated, the lines are less crisp, and there's actually kind of a bluish hue to what you see. And so the photo in the PowerPoint is some bison in the foreground, what feels like the foreground, and then off in what feels like the distance is kind of bluish, vague forms of mountains in the background. Okay, and in reality, I need to correct myself and say it's not that the bison are in the foreground, it's that we perceive the bison to be in the foreground because we can see crisp lines, and we perceive the mountains that are blue to be in the distance because of that blue tinge, the fuzzy lines, the lack of detail, and the low saturation. So I need to correct myself there because that was incorrect. Okay, the next one is called texture gradient, and texture gradient is on your list. And the photo that you see is a photo in the PowerPoint. You see this picture of just dense blossoms, flower blossoms, and they're of a Japanese quince of some kind. And if you look, you'll see that there are two like circles on that photo, and that circle, consider that like a unit of measurement. And in one circle, if you look, you can actually just see one big blossom. And if you move that across to a different part of the photo, what you see is like a whole bunch of little flowers in it. And so when we look at that, it's actually, texture gradient has to do with the density of items in a given unit of measure. So in the one case, you have one flower, and then you move it over, and now you've got a dozen flowers in the same unit of space. That's texture gradient. And so where there's only one, our brain interprets that as being very close, and when there's a lot, our brain interprets that as being far away. And if you imagine I used to teach at Heritage, and I would drive down, West Wapato Road, I guess, and there would be like wheat fields or any kind of agricultural field. But if you look kind of down and you see the first row of whatever it is you're looking at, I'll say wheat for the moment, the wheat kernels are just big, and when in your visual field you can only see a few, but then when you raise your eyes up just a little bit and look further down the field, there's a lot of wheat kernels in the same visual field. So our brain says when there are only a few in the visual field, that's close, and when you get a lot, so when they're dense, our brain says that must be far away. Okay. We just have two left, and I'm going to go ahead and make this just a little bit longer. So the next one has to do with the position of the information in your visual field. And you may hear me talking about position on the page, but that would be, imagine, anytime I say page, think visual field, okay? So one of the, let's see, position, actually we have three left. So position and visual field. So when I look out at the world, that's my visual field. And so if I'm looking at you right now, my keyboard, which I'll just hold up, is low in my visual field. And when I look at you, you're like medium in my visual field. And when I look across the room over here, that's high in my visual field. So our brain says things that are low in our visual field are close to us, things that are medium are further away, and things that are high are even further away. So in the classroom, when I look low in my visual field, I see the people in the front row. When I lift my gaze just a little bit, I see the people in the middle of the room. And when I lift my gaze a little higher, I see the people at the back of the room. And so my brain says, again, people low in my visual field are closer to me. People medium, middle of the visual field are a little further. And the people highest are even further away. Now there's one cue that's not on the PowerPoint that I want to at least mention, and that has to do with the position relative to a horizon. So if you have a horizon, so if you have a horizon in the distance, things that are close to the horizon, our brain says are wicked far away. And things that are far from the horizon, our brain says are close. So if you can imagine you're watching a plane take off on a runway and there's a horizon in the distance, when that plane is taking off, the plane is low in your visual field, and it's low relative to the horizon. And our brain says, that plane must be close to us. And then even as it flies up and it gets higher than the horizon, our brain still says, wow, that's so close to us. But as that plane flies off, it gets closer and closer to that horizon. And so things close to the horizon we see as wicked far away. And all of these cues are interacting and contributing. Okay, one last one, and then I'll let you go. It's called relative size. And relative size and texture gradient are very subtly different. In the PowerPoint, the photo for relative size is some balsam root yellow flowers, and it's this whole like meadow kind of thing with lots of these balsam root yellow daisy-like flowers. Okay, so the texture gradient was also a flower example with different density of flowers, but the cue is slightly different. So relative size has to do with how big the items are. So when you have a lot of the same type of object in your visual field, like a lot of flowers or a lot of people, things that are large are seen by us, our brains, as closer, and things that are small are seen as further away. So if you look at that photo in the PowerPoint, there's some flowers that are bigger, and the flowers that are bigger we see as close to us, and then those tiny little yellow dots we see as further away. If you're at a baseball game, it's the same kind of thing, where there are heads all over that stadium, and the large head that you see, we interpret that as that person is right in front of us. But the smaller heads that you see, we see as further away from us. So relative size has to do with the size, and texture gradient has to do with the density. And if you look at the photos in the PowerPoint, you'll see the difference. Okay, so I will stop there, and be sure to ask questions if you have any, and I will be working on another lecture. I will see you in just a bit.